Welcome to EDU World Space.
So in this question, the radius is equal to 15 millimeter, right? And the material that is used over here is steel. The tension that is applied is over here is of magnitude 2 kilonewton meter, right? And we are required to determine the strain along the x dash direction and the y dash direction, right? Now, the thing to note over here is that as there is no load that is being applied over here, right? So it means that if there is no load, so there would be only torsion present. And as there is only torsion present, so it means that there would be no stresses. It means the stress in the x direction is equal to the stress in the y direction, and that is equal to 0, right? And if there is no stress, so it means that there is no normal strain, right? So it means that the strain in the x direction is equal to the strain in the y direction, and that is equal to 0, right? So now, since this is all cleared up, let's write the strain rosette equation for 45 degree, right? So the strain rosette equation for 45-degree is the strain along the x dash direction is equal to the um, strain along the x direction cos square 45, and the strain along the y direction, sorry, it's the strain along the y direction sine square 45 plus gamma sub xy sine 45 degree and cos 45 degree, right? Now we just discussed that the strains along the x and y direction are equal to 0, so it means that these two terms would become 0, right? And we'll be only left with this term, so solve it and we'll get that it is equal to um, positive sigma sub x, sorry, gamma sub xy divided by 2, right? Let's say that this is equation number 1. Now what we need to do is that we need to write this strain rosette equation for 135 degree. Now how did we get 135 degree? So 45, right? So now what we need to do is that we need to write the rosette equation for 45 degree. So we have sorry, 135 degree. So we have 135 plus cos 135 degree and sine 135 degree, right? So again, these two terms would become 0 and we only left with this term, and solve it and we'll get that it is equal to negative gamma by 2, right? Let's say that this is equation number 2. Now what we need to do over here is that we are going to use the torsion formula 5.6, right, which is torsion maximum is equal to T times E divided by J, right? And recall that torsion is equal to G times gamma. Now what we're going to do is that we are going to compare these two equations and we'll solve it for gamma, right? And when we solve it for gamma, we'll get this expression, right? So what we're going to do over here is that we're going to just plug in the values and we'll get that gamma is equal to 0.00503, right? So just plug it back in equation number 1 and 2 and we'll get that it is equal to um, positive 0.00503 divided by 2. So that is equal to positive 0.0025, and this is equal to negative 0.00503 divided by 2. That is equal to 0.005, sorry, that is equal to positive 0.0025, right? So this is your solution.